Hello, good morning one and all. Today we will going to discuss about the next part in the network analysis unit number 3rd. There is a fundamental of the constant K type of the filters. Here in case of the constant K type of the filters, as per the requirement of the condition for the constant K type of the filter for the T section, there is a series arm impedance, and that series arm impedance is represented by Z1 by 2, Z1 by 2 and Z2. So that here there are the two inductor which is connected in the series arm and the capacitor will be connected in the shunt arm. Then this circuit is behaves as like the low pass filter. So that here is the Z1 by 2 and Z1 by 2, these are the series arm impedance, and Z2 is the shunt arm impedance. We have to be design this constant K type of the filter, and in case of the constant K type of the filter, low pass filter, the attenuation should be happen above the cutoff frequency. So that with the reference of this circuit diagram, we have indicate that this is the characteristics of the Z2 once the current is able to flow through the capacitor, and this will be indicated by Z1 by 2. These are characteristics which is to be happen with respect to the frequency. The current flowing through the inductor is goes on the increases. Here is the cutoff frequency, and for the cutoff frequency the attenuation should be happen above the cutoff frequency. Means only the lower cutoff frequency, the attenuation alpha, which is equal to 0. Then what we do here in case of the constant K type of the filter, for this case here basically these are the series arm impedance. In the series arm impedance, it will be give the attenuation for the below the cutoff frequency. For that cutoff frequency, which is called as the pass band, which is acting as the pass band, where the alpha, this alpha which is equal to 0, and here is the alpha, this alpha which is equal to infinity, alpha which is equal to infinity for the above the cutoff frequency. So that in case of the constant low pass filter, below the cutoff frequency, once the frequency goes on the increases, then current flowing through the inductor is also goes on the increases, as well as the current flowing through the capacitor is also goes on the increases up to this cutoff frequency. So after the cutoff frequency, what happens? The circuit is behaves as the attenuation alpha is goes on the increases, means till it is come to the infinity level, and for that infinity level the no any signal is passes through the circuitry above the cutoff frequency, and once the frequency goes on the increases, current still goes on the increases there, but the current flowing through the capacitor will be goes on the decreases, and it acting as the open circuit. So that above the cutoff frequency it will be attenuated, and the value of the alpha which is equal to infinity in case of the constant K type of the filter. Then Z0 which is equal to root of ZOC plus ZSC, means open circuited and the short circuited, its value with the help of under root of the value we calculated the output impedance. So in case of the low pass filter section, here low pass filter section, the reactance curve demonstrating, and the low pass section has pass band between the, here is the pass band between the Z1 which is equal to 0 to Z1 which is equal to minus 4 Z2. Then this is the variation between the phase as well as the attenuation, because the gamma factor, gamma which is equal to alpha plus Z beta, alpha plus Z beta, means alpha is stands for your attenuation and beta is stands for its phase. So that the variation of the alpha and beta with the frequency of the low pass filter, and from that low pass filter we have find out here the basically the beta is measured in the radian, and alpha is measured in the Nipper value. So that once the frequency goes on the increases from f upon fc 0.51, 1.5 with the difference of the 0.5, up to the 3. Then this is the cutoff frequency. Basically this is the cutoff frequency. F upon fc means cutoff frequency. After the cutoff frequency, your attenuation is still goes on the increases rapidly. Means from here is the stop band. It will be acting as the stop band. And here before this cutoff frequency, the value of the alpha which is equal to 0. That's why it will be acting as the pass band. So that in constant K low pass filter, only the low frequencies are able to transmit it below the cutoff frequency, where attenuation alpha which is equal to 0. Then we see its phase constant beta. The phase constant beta at initially it is the 0, and once the frequencies goes on the increases, its angle, means its phase is also goes on the increases up to this level. Means from just here, just before the cutoff frequency, your phase is constant. Means once the frequencies goes to transmit from input to the output side, where your phase constant beta is the unstable, still it will be going to be increases once the frequencies goes on the increases. But after the cutoff frequency, or just before the cutoff frequency, your phase constant will come for the stabilized position, so that this will be indicated at a constant level. So variation of the alpha and beta with the frequency for the low pass filter, it is shown in this diagram. So after that, this will be indicated by your ZOT upon RK with the frequency of the low pass filter, constant RK. So the value of the ZOT upon RK which is to be plotted on the y-axis, and F upon Fc is plotted on the x-axis. Then real and imaginary term. Once the attenuation alpha and phase constant beta is propagation constant, so that here the propagation constant is generally represented by gamma. Gamma which is equal to alpha plus z beta. See here is the alpha plus z beta. Then what we do here, once the alpha which is equal to 0, means your attenuation is a 0, and alpha which is equal to infinity, means it will be able to provide it the strong attenuation. Means whatever the operation of the filter, that will be decided by this parameter alpha as well as the phase constant beta. So that in the propagation constant gamma is the combination of the two part. There is a one is for the real part and secondary is the imaginary part. There is a phase constant. So that what we do here, we have to be plotted the response from F upon Fc with respect to ZOT upon RK. So what we do, from 0 to 3 and 0 to 2, from 0 to 1 is the cutoff frequency F upon Fc, and up to the cutoff frequency your low pass filter behaves as the short circuited, so that all the frequency will be come out from 0 to 1. So that here is the pass band, and from that pass band here is the real part should be happen, where alpha, and this real part is goes on the decreases, where attenuation will be here alpha which is equal to 0. So once it will be come to the 0, then your imaginary part will be start goes on the increases, phase constant, and where actually the attenuation will be started. Means your only the signal will be passes through 0 to 1 only, so that the variation of the ZOT upon RK with frequency is the low pass filter, it will be represented to the here. The next is the constant K high pass filter. In case of the series arm impedance, for the constant K low pass filter is that where inductor will be come in series and capacitor will be come in the shunt. And in case of the constant K high pass filter, we have to be connected the component just opposite to that of the constant K low pass filter. In case of the constant K high pass filter, where the capacitor will be connected in a series arm impedance, which is to be acting as the series arm impedance, and where inductance is acting as the shunt arm impedance. So that for this case, the Z1 by 2, Z1 by 2, here the capacitor will be acting as the series arm impedance and inductor will be acting as the shunt arm impedance. So that in case of the high frequency, as per the ordinary basic fundamental concept of the filter, only the above the cutoff frequency is passes through the filter, and below the cutoff frequency it will be attenuated together. This is the basic function of the high pass filter. So here is also, this is the high pass filter in constant K high pass filter. In case of the constant K high pass filter, where Z1 by 2 and here is the Z1 by 2 is acting as the series arm impedance and Z2 is acting as the shunt arm impedance. So that the reactance curve demonstration. In case of the reactance curve demonstration, the high pass filter or pass band between the Z1 which is equal to 0 to Z1 which is equal to 4Z2. Means as per the previous low pass filter, here is also condition about that the low pass section, the or high pass band between the Z1 which is equal to 0 to Z1 which is equal to minus 4Z2. Here is also your high pass filter or pass band between the Z1 which is equal to 0 to Z1 which is equal to minus 4Z2. So that here what happens, see, up to the FC means cutoff frequency, up to the cutoff frequency FC, it will be attenuate together, it will be the attenuate together, and where once the current is flowing through the circuit is goes on the increases, the impedance across the inductor is also goes on the increases with respect to the frequency. Okay, then here once for this case, once the current is flowing through the capacitor is also frequency is increases, its value is also increases, and the minus 4Z2 is goes on the decreases at a negative side. Okay, once for this point where the pass band will be start, is from that point at the cutoff frequency the signal will become out, and where attenuation alpha which is equal to 0, and the actually you want to getting the output from the filter after the cutoff frequency, and before the cutoff frequency the value of the alpha which is equal to infinity here. Then next is the M derived filter. Then what we do in case of the M derived T section and M derived pi section, that will be given as the same of the constant K type of the filter. In case of the M derived T section, the Z1 by 2 and Z1 by 2 is the basically the series arm impedance. And whatever the component should be available in the series arm impedance which is connected in series with the shunt arm impedance component, and for this fashion we have called it is the M derived T section. So the derivation of the low pass section having the sharp cutoff section or reactance curves should be given. Here is the low pass filter, and in case of the low pass filter after the cutoff frequency, here is the after the cutoff frequency attenuation should be happen. So once the frequency is goes on the increases from 0 to Fc, your current flowing through the inductor is also goes on the increases, because your conductor how much the current is flowing through the circuit L di by dt. Once the time is goes on the increases, its current changes with respect to the time is also goes on the increases. That's why it is the linear relationship. And once the current is flowing through the inductor is that there is capacitor is that once the current is flowing there, then continuously it will be your charging of the capacitor till up to the here. Okay, and the attenuation should be happen, then also the current is flowing through the capacitor is goes on the increases. Means before the cutoff frequency your attenuation factor alpha, which is equal to 0 and which is acting as the pass band. Means basically in the pass band the signal will be come out from the filter, and after the cutoff frequency where alpha which is equal to infinity, means it will be attenuated. Once it will be attenuated, then it will be stops to flow the signal. Here is the M derived low pass filter. This derivation we have seen afterward. Mz1 by 2. Here is the Mz1 by 2, and for the series here 1 minus m square upon 4m into Z1, and here is the Z2 by m. In case of the M derived filter, means Mz1 by 2, Mz1 by 2, 1 minus m square by 4m into Z1 and Z2 by m. This is the M derived low pass filter. And for this filter, the numerical example is expected in the examination to design the constant K low pass filter. So here is the variation. From that variation of the attenuation of the prototype M derived section and composite result of the 2 in series. So that here is the M derived filter. Once the frequencies goes on the increases where attenuation f infinity, and this is the prototype where the characteristic is able to show once the frequencies goes on the increases, then here the variation of the attenuation it is shown that here is your attenuation is represented by decibel as well as the nippers. Then here is the variation of the phase shift beta of the M derived filter. So beta is basically it will be stands for the phase, and for this graphical representation it shows that the relationship between the frequency versus the phase in case of the M derived filter. And one more thing you keep in mind, once you design the M derived filter, low pass filter or high pass filter, band pass filter, band stop filter is also. Here is the series arm impedance is always represented by Mz1 by 2, Mz1 by 2, 1 minus m square upon 4m Z1 and Z2 by m. And in case of the high pass filter, here is the capacitor should be available, so that there is a 2Z1 by m, 2Z1 by m, and here is the Z2 by mz2, and there is a 4m minus m square upon 4m upon 1 minus m square into Z2. In this way only these changes is happen in case of the constant K low pass filter, constant K M derived low pass filter, M derived high pass filter, band pass filter and band stop filter. You just keep in mind while you derive the numericals or to solve the numericals in the examination. So this graphical representation is shows that the frequency versus the phase shift. Once the frequencies goes on the increases, or this ratio is goes on the increases, definitely your phase is also goes on the increases. And from m which is equal to 0.6, after the f upon fc, your phase is still constant from here. See 1, 1 to 1.2, 1.2, then your phase will be constant, and after that it will be sudden towards the 0 level. This is the characteristics or relationship between the frequency ratio and the phase. Then variation of the Z0 over the pass band for T and pi network. Up to the here for your series arm impedance, in the series arm impedance, once this ratio is goes on the increases, then it slightly decreases, and your pi network is a slightly increases level up to this. Then this is the M derived T section, pi section formed by rearranging of your T network and pi network respectively. See, once the separate L section will be provided to the here, there is a mz1 by 2, mz1 by 2, 1 minus m square upon 4m into z1, z2 by m, and here is also mz1 1 minus m square upon 2m z1 into 2z2. Once it will be divided into the 2L section, I have talking about the this T section into the terminating half section, and in case of the terminating half section, the mz1 by 2 plus mz1 by 2, then it will be connected in the pi section. There is a mz1, only the mz1 is mz1 by 2, mz1 by 2, 2z1 by 2, then 2 gets cancelled, and here is only the m minus z1, and this pi section is the 1 minus m square upon 4m, means here is the 1 minus m square upon 2m into z1, 1 minus m square upon 2m into z1. Only this 4m we want to change here 2m respectively, 2m respectively, and this z2 by m is represented by 2z2 upon m and 2z2 upon m. It will be given. Then terminating half section, in case of the terminating half section is shown here, the mz1 by 2 and mz1 by 2, and here is the remaining all parts should be same, 1 minus m square upon 2mz1 and 2z2 upon m, and here is the 1 minus m square upon 2m into z1 and 2z2 upon m. In this way, your constant K type of the filter, M derived of the filter in T section, pi section and terminating half section we have seen here. Then variation of the Z1 of the L section over passband plotted the various. Once we want to goes on the increases the value from M which is equal to 0.21, then this ratio Z1I upon RK, this will be constantly goes on the increases. Okay, so up to the here we have seen the constant K type of the filter, M derived filter, the terminating half section, then constant K, low pass filter, high pass filter, band pass filter, band stop filter, then M derived filter and its T network and pi network and terminating half section we have seen in this video. I hope that all of you understand the concept of the constant K type of the filter and M derived filter. Please like my video, please subscribe my channel, don't miss to press the bell icon. Have a nice day.